So question 13, and this is our silver award winner for the dodgiest question on the exam. Let's go see why. So if we scroll up a little bit here, we've got a graph, and part A says identify the shortest Hamiltonian path from the warehouse, which is warehouse is at A over here, and state its length. So the Hamilton path means we've got to visit all the vertices once. It's a path, so we mustn't end up back at A, and that's about it. So there's no real method for doing these, but the shortest one, we could try something like the minimum spanning tree, looking at the numbers on the graph, starting from A, and see how that gets us going. So if we start at A, we can go down to D for 14. That's the shortest way out. The next shortest edge is the 10 up to C. The next shortest edge is 8 up to B, and then we've got a 12 to E or back here, but we're trying to keep it as a path so we can't come back. So if we keep going to E, then the shortest is to G, then the shortest is to H, and then the shortest is to 10. And by kind of using the minimum spanning tree, we find we're finished. So on that one, that's it. The path ABC, ADC, BE, G, H, F, and the length is 70 kilometers. So let's move on to part B and see what's happening there. We must be made from warehouse at A to retail outlet H, and we've got to determine the shortest path and the distance traveled for this delivery. So far so good, but then the examiner pops in working must appear on the network to show an appropriate method has been used. Now, the only appropriate working that we can show on the network typically is Dijkstra's algorithm. But the syllabus says investigate and solve this type of problem by trial and error methods only. So this is why we get the first blooper on this question. Really, the examiner, if trial and error methods would be, we try sort of A, C, H, write down that the length of that path is 48, and then we try another path, A, B, E, G, H, write down the path. And so we're just trying lots of paths, writing them down systematically. But we've got to show working on the network. Now, most schools do teach Dijkstra's algorithm, so I'm guessing that the kids are going to go all right. Basically, it works like this. Yeah, we start with a 0 at the start, and then we're working our way across to each vertex, writing the shortest distance from A to that vertex. So to get to B, we can either go via C and up or straight there. Straight there is shortest, it's 20. To get to C, we could go up to B and then down, but obviously that will be 28. 22 straight there is the winner. And to get to D, obviously 14 straight there. Then the next one maybe is to get to E. Only two ways, 20 plus 12 is 32, or 22 and 18, which is more. So we'll stick with the 32 in that box. Downstairs, we've got 22 and 12 is 34, or 14 and 26 is bigger than 34. So we'll take the 34 and pop that into there. Right now we need G. So to get to G, it's 32 plus 10. Coming round the long way isn't going to help. So then to get to H, we've got 42 and 6 is 48, 32 and 18, which is 50, 22 and 26 is 48, or 34 and 10 is 44. That was the smallest of the four ways in, so that's the way we go. And then we backtrack to get our route. So A, C, F, H, but that's using Dijkstra's algorithm, and of course that's not in the syllabus. And if they wanted it there, why don't they put it in instead of talking about trial and error methods? Anyway, we'd like it if the examiners read the syllabus from time to time. Moving on to part C. This is where the examiner really gets a little bit confused about what's going on. At the moment, road CH here goes around a dry salt lake, and it's proposed that a direct road be constructed that will reduce the distance between them. Fine. But then in part C, by how much can the direct road be reduced? But wait, we haven't built it yet. How can we reduce something we haven't even built yet? So it's kind of a bit of a nonsense. Now, I'm not guessing that this isn't going to bother too many people in an exam. Their heads down, steaming through these questions and not really reading anything too carefully. But I'm sure we could have done a bit better here. Anyhow, let's have a crack at this. So, how would we do it? So here's a copy of B. There wasn't actually, I don't think, a diagram on this page, but I've got to just chucked a copy over here. So this was what we had, and at the moment the shortest path is 44. If we go ACH, which would be the way, the route that includes CH, obviously to get to C, the quickest way is 22. We need, at the moment, it's 22 and 26, which is 48. So we need to reduce it by 4 kilometers to make sure, but also by how much can the road be reduced? So we could actually reduce it more than 4. And the most we could reduce it by would be 26 kilometers, so that it actually C and H were right next to each other with no distance in between them, if that was physically possible. So my answer to this would be that CH can be reduced by between 4 and 26 kilometers, so that the shortest path includes it. Now, of course, practically that might not be possible, but anyway, yeah, it's a pretty dodgy old question.